Hi. The next rule we are going to deal with is called product rule. This rule allows us to find the derivative of a function which can be thought of as a product of two different functions. Okay, so let's start with the proof, and then of course we're going to move on to examples. Okay, so we are looking for derivative z prime of n, and of course this is equal to a limit with x approaching n out of z of x minus z of n divided by x minus n. Okay, now let's utilize the information we've got over here and let's substitute for z of x, and we'll then have f of x times g of x, and for z of n we'll then have f of n times g of n. Okay, so we've got the limit with x approaching n out of f of x times g of x minus f of n times g of n. Okay, and this all divided by x minus n. Okay, look, it does not look like something we can do with it at the moment, but look, what I can always do is that I can always add 0. Okay, and look, what do I mean by that? A limit with x approaching n out. Look, over here we will have f of x times g of x, and over here, somewhere at the end, we're going to subtract f of n times g of n. And look, I'm going to add 0 here. Okay, why would I be adding 0? It doesn't change a thing. Look, 0 can be expressed in various different forms, right? 2 minus 2 is 0, right? So let's use the trick like that, and let's over here put an expression minus f of x g of n plus f of x g of n. Right? So we've got minus f of x times g of n plus f of x times g of n, which of course is equal to 0. I've added 0 here, so I didn't change anything. Okay, but look, now that we actually added this expression, we see that there are some things we can do with it. I'm going to do it very slowly. And so, look, first, let me divide this into two separate fractions. So, we will have that this is limit with x approaching n out of f of x times g of x minus f of x times g of n over x minus n, and over here we will have a separate fraction, right? So we will have plus f of x times g of n minus f of n times g of n. Of course, divided by x minus n. Okay. Now it starts to look a little bit better. Now, what else can we do? Look, I, for example, can take the common part, f of x, out of these two expressions, and common part, g of n, out of these two expressions, right? So I'm getting that this is the limit with x approaching n out of f of x times g of x minus g of n divided by x minus n and plus g of n times f of x minus f of n divided by x minus n. Okay, I hope it already starts to look like something, but let's remind ourselves a couple rules associated with limits. Limit of a sum is sum of the limits. So I can divide these two into two separate limit expressions. Then we know the limit of a product is product of the limits. So I can divide those two separately and those two separately. So then what will I get? I will get that this is limit with x approaching n out of f of x times limit with x approaching n out of g of x over minus g of n over x minus n plus limit with x approaching n out of g of n times limit with x approaching n out of f of x minus f of n over x minus n. Okay, and at this moment we are ready to calculate what it is. Look, limit of this function as x approaches n is going to be equal f of n. We're assuming that the function is differentiable to begin with, so we can find the limit in this case by substitution. Now, times what? Let's look at this expression. Or maybe it would be even better if we start by this expression. Does this look familiar? What do we have at the top? At the top, we have delta y. And what we have at the bottom? Delta x. And in this setting, this can be thought of as delta x approaching 0. Look, this is a limit with delta x approaching 0 out of f of x. So this is the definition of the derivative of f prime of n. And look, by the same token, this expression is the limit of the function with x approaching n out of at point n, so g of n. So this is g prime of n. Now we've got plus g of n, right? Because we already have n over here, so we don't need to even change a thing. And finally times f prime of n. And now we have actually proven the product rule. Okay. So, how now? So let's write the final final formula, and the product rule says that derivative of product of two functions, so of f of x times g of x, is equal to, let me just change the order because it doesn't really matter, and it will serve as kind of a mnemonic device a little bit later. So it's equal to derivative of the first function times the second function plus first function times derivative of the second function. This, what you see over here, is the so-called product rule. Okay, now, And let me show you this on some examples. Okay, let's just say that we've got a function y equals f of x, and this function is given by 9x squared minus 2 times 3x to the power of 3 plus 2x. Okay, look, of course you can say that if we want to find the derivative of this, we could multiply the whole thing out. But as you will learn a little bit later, it's not going to be that easy with every function. So how do we do it? Look, you need to imagine for a second that this is a product of two functions. Function f of x and the second function g of x. And look, now all we've got to do is to apply this formula. So we get the dy dx. First, I calculate the derivative of this function. I get out of it that this is simply 18x. Right? And what should I do next? I should multiply it by the second function. Then I should add, and now look, we do the same but in opposite order. So I leave the first function the way it was, so it's 9x squared minus 2, and I multiply it by the derivative of the second function, which is 9x squared plus 2. Now, this is the ready result. Of course, at the exam, you need to calculate, multiply everything out, but for now, this is not the point. We are just practicing the rule, so this is how we're gonna approach it. This is how we're gonna leave it. Okay. Now, let's do one more example. Okay, so if we have y is equal to 7x to the power of 5 plus 3x squared minus 2 times 4x to the power of negative 3 plus 2x squared plus x. Okay, again, we can do it in exactly the same fashion. We are imagining this is our f of x and this is our g of x. Now, how? So, what should we do? What should we do now? Look, we just follow the rule. So, first, I find the derivative of the first function. The derivative of the first function is 35 x to the power of 4 plus 6x, right? And I multiply it by the second function. This one I do not touch. So it's 4x minus 3 plus 2x squared plus x. Then, at this moment I'm halfway done, right? So what I need to do now is to add to it. I now rewrite the first function. So I got that this is 7x to the power of 5 plus 3x squared minus 2. And then I differentiate the second function, right? So I get negative 12x to the power negative 4 plus 4x squared plus 1. Again, this is our result. Okay, now look. This rule is extremely useful. But what about the case where there is a product of more than two functions? As it turns out, the rule is very easily extended to those cases. And let me demonstrate that. Look, I'm not going to be proving that because it would gonna be it would be rather time-consuming process, and we could end up. I'm not going to be proving that using the definition because that would be a very time-consuming process. Let's just use the information we already have in order to find the derivative we are looking for. Okay, so now imagine that y is equal to some m of x, and this m of x is equal to a product of three functions: f of x times g of x times h of x. Okay, remember before we were calling this part z of x, right? So why not use the same trick? Because look, I can always think about this as one function and this as the other function, and because of that, I'm going to get a product of just two functions. So look, I've got that this is z of x times h of x. Okay, so now, if I want to find the derivative of this, right, all I need to do, is to use the product rule that we've got over there, right? This is going to be z prime of x, right, times h of x plus z of x times h prime of x. Okay, look, we already know how much is this, right? This is equal to, okay, we'll have z prime of x times h of x plus, and we know that z of x is equal to f of x times g of x, and now I just need to multiply it by h prime of x. Okay, so what we do not know? Well, we do not know how much is z prime of x. But is it really that hard to complicate it? But is it really that complicated? Look, z prime of x is just derivative, is just a derivative of z of x. So this is a derivative of f of x times g of x, right? Because z of x is equal f of x times g of x. Okay, and we already know how much is that. We know that this is equal to f prime of x times g of x plus f of x times g prime of x. Okay, so let's take this result that we've just obtained and let's substitute it over here. Okay, so what we're going to get here is an expression that's going to look like f prime of x times g of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. Okay, now look, all we need to do to get the final result is to multiply everything out. And I'm getting that this is f prime of x times g of x times h of x, right? I just multiply each component by h of x. Then I get that this is f of x times g prime of x times h of x. And then I'm just adding the last one, f of x times g of x times h of x. And now, look, what we did is we actually found the derivative of this function. We just rewrite it in a different form, following exactly the same logic as we had over here. So, look, now, putting this all together, we get that, okay, give me a second. Okay, so, derivative of a product of three functions, f of x times, say g of x times h of x is equal to f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g prime of x times g of x times h prime of x. Okay, and look, I hope you notice a very simple thing here. If we differentiate this expression, we get exactly the same expression three times, but each has just one difference. In the first one, instead of first function, we've got derivative of the first function. Instead of second function in the second expression, we've got its derivative and the derivative in the third expression. Okay, let's just make a quick example to show how the rule works. Now let's just say that y is equal to 3x squared plus 2 times 6x to the power of 3 minus 7x times 4x squared minus 1. Okay, so what is dy dx? Look, again, we can imagine that this is f of x, this is g of x, and this is h of x. So, we just need to apply the rule. So, first, derivative of the first expression, we get that this is 6x, right, times the latter two expressions. 6x to the power of 3 minus 7x times 4x squared minus 1. Then plus, and now we rewrite the first expression, 3x squared minus 2. We differentiate the second expression, so we get 18x squared minus 7. And we rewrite this third expression. And finally, we rewrite the first two expressions. And we differentiate the last one. So we've got that this is just 8x. Okay, simple enough. And look, knowing this, we can go even further. Because look, I hope you can see the pattern over here. If we would like to have two functions, and now if we would like to have a product of four functions, we can apply the same reasoning to get the result there. How? Well, look. If I, for example, have the function y and y equals f of x times g of x times h of x times some n of x, so we've got four functions. Look, what could I do over here? I could, in the first step, I could say that this is m prime of x. Oh, sorry, m of x, right? The first function. Then I could say that this is n of x. Then what would I do? I would calculate those two, and I would calculate the derivative of this using product rule. Then I would substitute, and again, what I would get as a result would be expression in the similar form just slightly more complicated. But look, I hope at this moment you get how this expression would look. Because look, it will have 4 components. In this case, look, what would we have? We would just simply have to take this and rewrite it. So this would be, for example, some L of x. I'm sorry, too many letters. Okay, so what we've got now, are 4 different functions, right? Let's rewrite them over here 4 times. F of x times g of x times h of x times n of x plus f of x plus g of x times h of x times n of x. And 2 more times. F of x, g of x, h of x times n of x. Then plus f of x times g of x times h of x times n of x. Okay, so what do I need to do with this expression to get a derivative? Well, it's very easy. Add derivative instead of first function in the first expression, derivative instead of the second function in the second expression, add derivative instead of the third function in the third expression, and derivative over here. And look, by the same token, knowing this, you can extend this rule to any finite number of functions. Okay, so thank you for your attention. In the next video, we're gonna deal with the quotient rule.